this is the second part of S4. Here we talk about convolution in the frequency domain. We'll show you convolution done in the DTFT domain, as well as using DFT to realize the linear convolution, followed by some examples. Let's begin convolution using the DTFT. Well, if we have y of n, we know that by performing DTFT, we get y of omega. Y of n minus 1, the DTFT is y of omega e minus j omega multiplied by the delay. In this example is 1. If the delay is d, then this will be d. So once we have this, we are actually converting the signal in time domain into the frequency domain, and we are using and exploiting time delay properties in the frequency domain to make it algebraic. So what I'm saying is this: y of n becomes y of omega. What about this guy? Becomes y of omega e minus j omega times 1. What about this guy? Becomes x of omega. Now you can manipulate these equations just like algebra. You realize that we can have this. Y of omega is this guy times this. X of omega is this. And by putting y of omega over x of omega, we get the important frequency response representation of the LTI system. Alright, once you have h of omega, you can then multiply by x of omega, whatever is given. In this case, is this signal over here. And then you can find y of omega, and then by inverse Fourier transform, you can find y of n. Now I put a big cross here because doing it in the DTFT domain is actually quite complicated. Later on you will realize that I'm going to use the Z transform to do this convolution, which will be much easier than doing it in the DTFT domain. Thank you.